Hi
Hi.
there.
Hi.
Hi there. Sorry so much about the wait time. I apologize. I got caught up in a couple of things, but thank you for taking the time to meet with me.
No problem.
Thank you so much. So, yeah, my name is Mihir. I run some clubs at my high school where we learn about computer science, AI, robotics, and we were really interested in a lot of the work that you were doing with human-computer interaction and some machine learning stuff. So yeah, we just wanted to call and talk to you and learn a little bit more. We have some questions that we'd love for you to answer if possible.
Okay. Hi, Mir. I'm Yasra. I'm a PhD student at UMass ECE, and my work is, as you explained, it's human-centered computing with the tools that I use it from systems, ML, and HCI. So that is my work. The high-level problem that I want to solve is that the application that I'm focused on is mixed reality, augmented reality, and what I'm trying to do in that to figure out like how being the human, it's a human-centric application. Human is at the
Mhm.
center of it. How the human being in this system changes it, and how can we make sure that the system can learn from human, but also the system is well optimized for that human who's the center of it.
Sure. Okay, for sure. Yeah. I think so to get started off here, I think a lot of the students here are still trying to figure out how to progress in their journey with computers and engineering. So maybe if we could start by if you could tell me a little bit about like yourself, you already did, but like a little bit about yourself and like your journey in HCI, computer science, about anything you like to talk about, like about yourself and how you've journeyed in this.
Hmm. So I did my undergrad in back home in Pakistan, and my undergrad is in software engineering. So in my undergrad, basically what I learned is like how to code a certain problem. So whatever problem you give me, I was able to figure out and how to solve it and logically design the system around it. But what I did not learn is like what is the technologies around that? Like so software engineering is a tool, but like how can I expand that and look for different applications? So I did my master's from State University, New York in computer science. So in that, I learned a breadth of information about different areas, including security, privacy, sustainability computing, data engineering, and like HCI, all of these like systems that I learned about. And then I started my PhD in UMass in electrical and computer engineering. My focus is basically computer engineering. So now what I'm doing is, and how I work through it and how I led up with this work is
Mhm.
at different stages of my career, starting from my undergrad. When I started my undergrad, I didn't know how to program. I didn't know code. I did that like back like 10 years back. So in that point, people like were not learning to code at school. So I did not learn any coding in my school. But I just like learned everything on the job, and then I worked with a lab where I learned how to program sensors and how to
Mhm.
program the OS behind the sensor. So I was
Right.
writing a lot of firmware, which means that the tiny devices that you get, they have like little
Mhm.
OS built in. So you
Mhm.
need to program and you do need to change something to get the data out of it. So I was doing
Right.
a lot of that code. So at every step, I just like I use the skill that I learned and I just like
Mhm.
learned a new skill. I just like keep patching new skills.
Right.
So I learned how to work with sensor. Then I learned how to write this OS operating systems for it, how to write the protocols for it, not just like the low level applications, but like OS level codes.
Right.
And then I moved up and I worked into a lot of like in one part of my career, I've worked on writing codes for like sustainable computing. Like I was controlling a lot of devices, and from that, I was trying to figure out when to turn on some fans or when to.
Right.
I also did like some grid engineering and all of that. And then I led up to this mixed reality application, which has like, in my PhD, the thing that I learned is like HCI, which means that in all of the application that I was working with, for they did not have like all of the application are made for humans, but like the
Right.
human was at the center of it. So in this one, I learned the skill of like human-centered interaction. So my like journey basically summarized that every step I learned a new skill and attached it to the skills that I already have. And it was
Right.
not like isolation of like vacuum of different skills that I have. I
Right.
always tried patching up the skill that I have, and that's how I have like a really big tool set in my hand that I can pick and choose like which problem would need which tool. And I'm sure I would be learning more skills as I go.
Right. Yeah, I think that's really interesting. I think, when I think of like a PhD student, I sometimes think of someone who has identified something that they're interested in at I don't know, some maybe late in the undergraduate stage and just they've stayed the same course the whole time. But it's very interesting how you've always added on and learned more things and breadth of knowledge, a lot of information. So I think um, kind of adding on to that question, right? As younger students, some of the things that we're interested in is, trying to find that spark, right? How we start up into that field, right? I know you're from Pakistan, you started in software engineering. If you could maybe talk a little bit about like what initially sparked your interest in, whether that be software engineering or computer science in general, just how did you like get to that point where you were convinced that, this might be a field that I'm interested in exploring.
Yeah, so when I started my undergrad in software engineering, I was just doing it for the sake of it because, like, oh, software engineering is cool. Everybody is doing it. I should do it. I should learn about it. That's how I started with that. But when I started to work with sensors and devices, that is where I found like, oh, I love this work. It's just not like I'm just somebody gave me a problem and I'm just like coding that with a logic. I also have to figure out like there's a physical phenomena attached to it right now. So that's how the whole thing, like the sensor data and all of those things, and when I that's how the journey to mixed reality ended up being, because like mixed reality is just like there is a bunch of sensor on the device and they're just like collecting data about the sensor, like where the user is, where what the
Right.
scene is around the user and how the user is interacting. It's all about sensor data. So it's just like one of my classes that I took, I think in our undergrad, we were supposed to take classes from like all major engineering fields like electronics, mechanical, and all of that. So I took one class on electronics, and from that I knew that, oh, I really like this work. I should continue that. And then I applied to a lab which was doing a lot of this work. So in my work, I did like energy transference through lasers. So I was using a lot of sensors and a lot of servo motors and lasers to actually transfer the energy. So that is sparked a lot of interest. And I also like the process of research.
Mhm.
I'm not per se a software engineer type of person anymore. I am a software engineer, and as you said, there is like a slight difference. Like software engineers, they have a problem in their mind and they are like problem oriented and they would solve that problem. But researchers are not just like they would just like look at the phenomena and they would see that if there is something interesting in that or not, and
Right.
and they will build knowledge on that. So I like that part a lot, and I just build these
Right.
skills as I go.
For sure. I think definitely the idea of research versus just being like an industry engineer is definitely a different aspect. Researchers spend more time on problems definitely compared to engineers. And I think also touching back on what you said before, one thing that I've noticed is, in our high school, we don't really have like organized coding or anything, but people who are interested will do things like hackathons for fun, right? Small hackathons. But one thing that we're always lacking is that physical aspect. We'll build an application and it's just somewhere up on the web. And I feel like we're missing some of that satisfaction with, seeing the results happen in real time and having the interaction there. I think that that's an interesting aspect that you bring up. And I really am fascinated by the idea of mixed reality, where you're mixing both the computers and the physical using sensors to make everything work together. I think that's really cool stuff.
Yeah. On that, I think the aspect, like, because of Python, everything is on like, laptops now. But I think that this like actually doing something on the devices is very easy to do. I think you can ask your school to bring up like some people like me who are doing this work, or maybe
Right.
just like, having a course or like a crash course or summer courses on like small boards, like embedded system boards like Arduino, some BeagleBone Black, Raspberry Pi. In that, what you do is like you're not just writing a code for some application that is running somewhere in the cloud. You would also be able to see like, oh, I just designed this application and this is
Right.
telling me some input from the environment, like sensing something from the environment. If it even if it's like just as small as like sensing a temperature, but you would see that happening in real time, and that will tell you that will tell you so much about like, how the data is collected, the
Yeah.
amount of data that we see on the internet. That's how this data is collected.
Yeah, for sure. I think that's definitely an interesting idea. I think some people have discussed working with Arduinos, but I'm not sure that's exactly, something that a lot of people have done. I think, you know, uh, yeah, I think that that's definitely a different aspect of it, like being able to experiment hands-on. I think not exactly stemming off, but kind of switching categories here. Um, we're really interested in a lot of your research with mixed learning, and we were, if possible, we were wondering if you would be able to give us like a simple overview of some of your recent interesting research. When I found out about your work, I was looking specifically at stuff at ISEMV, the conference there,
Yeah.
and also some recent work on, I think, at IROS, the robotics conference. So I think if you could maybe just briefly go in depth on any one of those, that would really be interesting.
Yeah, I can go in depth with the IROS work that I'm going to present in a week. I'm going to
Oh,
Abu Dhabi.
really?
Yes.
Amazing.
So the idea of this work is like you've seen like tracking systems everywhere, like
Mhm.
like now with the Teslas, and we have drones that are flying in, and the mixed reality when I wear a AR VR headset, there is a tracking going on. But what is the problem in that? The problem in all of those tracking algorithms is that they are not still very safety critical. So if you travel in Tesla, you would see that if the weather is not right, Tesla will keep beeping that, oh, take the control, because like
Right.
the
Right.
weather change is like very hard for the algorithm to learn. So these are the like a lot of examples. Like I'm wearing a AR headset, and if I'm going from a room which has a lot of information, like there are tables, there is like chairs, beds, there are a lot of information to collect data from. And then
Right.
as I go into the corridor, there is nothing. There is just like white walls.
Mhm.
So what like algorithms need is like a lot of features, like a lot of small points in the environment to track where
Sure.
the user is. So whenever we change the environment, or an environment doesn't have a lot of texture, what
Mm.
happens is that these algorithms fail.
Yeah.
These algorithms either have massive errors, or they actually stop working, and you would have
Right.
like that you would hear. So my work was like, how can we make it more adaptable to different environments? So what is the way to do it? Because like the algorithms right now, the feature extraction is like they are mathematics based because they are very reliable. So when
Right.
I say mathematics based is like symbolic architecture where
Hmm.
they have like, okay, so this is the so feature extraction is basically, so algorithm looks at our data, like image data, and try to figure out some points in the image. And
Right.
that image will be keep tracking the images as the images keep coming, keep coming.
Hmm.
So it will keep tracking those images, those feature points.
Points. Yeah. Hmm.
And the goal is to find the features that are going to be traced for a long time. That
Hmm.
there are good features to track. There is like a
Hmm.
metric called good features to track.
Right.
How do we tell the algorithm that how do you set your parameters to find as many good features to track as
Hmm.
possible? So my
Hmm.
eye focus on that. So I looked into like, okay, if I just do like symbolic one, like where I'm just like telling mathematically, what
Right.
happens with that is like I wouldn't have like I wouldn't be able to define all of the environments that I could see in mathematical
Sure.
terms. Because
Sure. Hmm.
let's say if I define like thousands environments, there would be like next environment that I wouldn't know, that my algorithm wouldn't
Right.
know.
Right.
So there is a technology called neurosymbolic architectures, which means that neural networks have like a lot of deep learning, so which can
Hmm.
infer a lot of from the data, it can infer like what's going on, and it can learn from the patterns from the data. You wouldn't know how it learned it, but it could learn.
Right.
So what I did was I devised a domain specific language. I
Mhm.
like code for that, and like as soon as let's say if I'm running an algorithm on car or drone or
Sure.
headset, I would give that algorithms, and what it would do is like first neuro with using the neurosymbolic architecture, it would find like based on where the environment and what the environment looks like. If the lighting is too high, what the parameters of the feature should be. If the lighting is too low, what the parameters should be to have
Right.
the optimal working. So I just wrote like a neurosymbolic symbolic feature extraction, which is NFAX that my system is called. And from that, what we saw is like just by changing this, like how to find the new parameters for the feature extractor. We do not change anything in the feature extraction yet. We just found like the best parameters. So what
Right.
parameters feature extraction would have? Feature extraction would have like what is the scale should be, like how long we should keep tracing this particular feature,
Right.
how the feature is going to look like in the next frame. So I wrote the domain specific language, which means that it is not just like a Python. It is a new
Right.
language altogether that
Hmm.
knows how the feature extraction work. So I wrote a big knowledge graph in my
Right.
code that would understand what the feature extraction is. So I'm explaining to the algorithm what the feature extraction is and what the different environments are going to tell that.
For
And
sure.
from that, the feature extraction, like my NFX system is going to tell the algorithm, like whatever the tracking algorithm is, it will tell like, oh, this is the best feature parameter right now for you.
Right.
You can pick them so that you have either no error or very less error. And
For
we show
sure.
that 90% of the time when we do it, like we are actually working about like 90% better accuracy than the other
Wow.
ones that are working at the state of the art right now. So that is my work that I'm going to present in IROS. So
Yeah.
it has some symbolic architecture, which means that a lot of computer science work and understanding what the tracking looks like, then a lot of deep learning to figure out how to write
Right.
those, how to code those knowledge graph into a deep learning model. So it has like a lot of interdisciplinary work, and I
Yeah.
published that in a robotics conference because tracking is very relevant to them.
Right. Yeah, I think that's interesting. I was just about to touch on like that. It encompasses so many different fields, and I think that it's really fascinating work, especially coming up with a whole, starting a whole new language, to make this more efficient. I think it's really interesting stuff. I do have one question, right? Regarding that, at least from so the way that our club runs, right? Maybe some context is weekly we'll meet and we'll discuss some papers, right? And we think that it's a good way to learn about these things. And one thing that's been reoccurring is this idea of accountability and making sure that these language models have some reasoning behind why they make actions. Because especially when you want to implement them, I mean, you probably know this better than I do, but like when you want to implement them in the real world, you want to make sure that there's some way that you can determine why something made that action. So you talk about how the your model will make the decision. I'm not sure if you did mention this, but how we're not exactly 100% sure how it made that decision. Can you elaborate on how you might have considered that or how you mitigated these different ideas?
Yeah, so the whole idea for like neurosymbolic architecture comes from the explainability. So what happens with like machine learning? Machine learning is a very great tool. So it will help you look for the data that is unseen, and it will find the patterns that the human eye cannot find, or like the mathematical function that we can't write to figure out those patterns. So it is really good at that. But as you said, like it is not, so it is a black box. You don't know what happened inside it.
Right,
So neurosymbolic is a really good balance between, because I need the power of this like deep learning model, which will tell me what are the patterns that are occurring in this scene.
right,
But what symbolic knowledge is doing, like I am coding my knowledge graph myself. So I know. So let's say if the failure happened, I will be able to backtrack my knowledge graph to figure out why, at what point the tracking actually failed. So that is the
right,
like neurosymbolic is a really good balance between having having the interpretation and reasoning from the symbolic part, like I'm writing all of those things, and then like having a power of like doing like the work for big tasks that I don't know how to solve. Like, I can't explain each texture to my algorithm symbolically,
right,
but I can teach what is going to happen when
for
we
sure,
run the low texture environment in the
for
feature
sure.
extraction. So that's how we mitigate that. So I think neurosymbolic architecture is a very good representation of like the balance between the reasoning and like getting the things done, which require a lot of manual effort.
Right. I think that's really interesting. I think um the idea that you can have these like knowledge graphs embedded into these models is not something that I've come across in some of the reading. I think that's definitely something that we'll explore in more in depth because I think that I'm not you maybe you'd like to give your input on this. Do you think that this is a future a very a promising future direction? The way it sounds to me, I think that this kind of remedies the whole idea where we need we want the efficiency of the neural networks, but we want the reliability. And now we can almost get some or work towards this progress with these models.
Yes. Yeah. So neurosymbolic is like a really big field right now. And a lot of people who are working in programming languages, they started with this like whole neurosymbolic architectures. And the idea came from like, let's say if you're running a algorithm in surgery, like it like so surgeon is wearing a headset. So that is considered a critical application, like search and rescue, all of these applications are considered as critical applications, which means that so it is not just important that they work and have a good accuracy. It is also important that we can backtrack and we can explain if the failure happens. So all of these architecture, the neurosymbolic architecture. So this is one of the problems that I solved. But like in neurosymbolic architecture, people are reasoning about the Q&A, the prompting that they are doing to Chat GPT, how they're defining the visual scenes, how they are doing the object detections, how they're doing face recognition, all of these applications that require some sort of explainability that you did some search in ChatGPT, you need to know how that ChatGPT came out about to that point.
Right,
So you can fact check that.
right,
So the ChatGPT O that came out, it is based on reinforcement learning, which uses the same principle as so they are not putting a lot of like symbolic parts. That's why it is still not factually correct, but
right,
it is still trying to backtrack the knowledge of like what is the knowledge that I created. I want to go through it and then I'm gonna make some suggestion. Unlike before, where ChatGPT would like go do a random
right,
internet search and will tell
right,
you
right.
the answer that would look correct, but it would
Mm-hmm.
not be, would
Right,
mostly not be correct.
right,
So yeah, this is like one of the fields that people are doing this work. The other works are like how we can. So this part is like how to make it more explainable. So neurosymbolic architectures are one of the ways to do it. The other people, what people are doing is like they're tweaking their models and they're trying to figure out how to make those models more fairer.
right,
Which means that not just we are able to explain what happened, but we want to make sure that let's say if you as a young adult query some model, and I, as a woman, um,
right,
do that, would I be able to get the same answers or not? Let's say if
right,
it's a face recognition, we both wear glasses, but I'm a woman, I'm much older than you, and you're a young, male presenting
right,
person. So how would we do it? And let's say if we bring in someone who's non-binary, who doesn't conform to any gender, how would we go about that? Like how
right,
would we talk about that? Like so let's say if you are male presenting, it would presume you that oh you are a man, and if I'm female presenting, it would presume that oh you are a woman, but not
right,
necessarily for like because we now the
right.
gender is different. So
Mhm.
we are adding these type of information and teaching this type of information, which is not like point A to B. It is like really nuanced. It's very different
Right.
to argue. We are trying a lot of like machine learning efforts are going in like a lot of there is a conference called FACT,
Mhm.
FAACT.
Right,
It's
right,
all about like these ethical, and I think you would enjoy the papers from there.
for sure.
They do a lot of papers on ethical consideration, fairness, accountability, explainability of AI
Mhm.
models. And we have like one paper in there last year, but I think that would be really interesting for you to read. And people
Sure.
are looking at different angles of how the fairness and accountability should look like.
Right. Yeah, I'll definitely take a look. I think that's definitely an interesting field. I think regardless of advancements in all of the different like in model developments and all these things, the conforming with social standards is always an important task. So I think that this is making sure that equity is there and having all the inclusion, it's always an important idea. So I mean, it's always that's a recurring theme, I think for sure. That's different, definitely important.
Yeah.
Um, so I won't hold you for too long. So I think last question here. As a PhD student, right, and going through all the opportunities and everything else that you've gone through, what advice would you give to, I say a high schooler, maybe a young undergraduate student, someone at the beginning of their career who's interested in pursuing a career in, maybe we'll talk about human computer interfaces or computer science or machine learning, just whatever advice, general advice you'd like to give.
I think the biggest advice is like reaching out to people, like you have done a great
Right.
job, you know.
Mm.
Um, first is like you all are getting together and reading papers and looking at what is going on in the field,
Right.
and don't hold like, and I like this idea. So when you read the paper, you might not know how everything is executed, and I am the same. Like, I am, when I read someone else's paper, I might not know how they executed that, but I will still read that paper to get some new ideas. So
Right.
the way, like, looking for new ideas and trying to make some way through it without even knowing how to get there or how to solve this specific problem. If you just know this problem exists, that
Yeah.
is a big, big win. When we come to like execution part, I think execution part is like, there are a lot of NSF programs that run for high schoolers. So there is one program that is running Turing school that runs. So look out for like summer programs where they're teaching about some specific computer science field that you are interested in, or some in like general programs where they are talking about the breadth of work that is going on in the
Right.
technological fields. So you could do that. Like, this is like, one is like reading about it, one is like actually getting involved. And the third is like, keep finding mentors like you keep reaching out to people who are doing this work, asking them about like, can you talk to us? Can you tell us about something? Can you give us some resource that we can learn online, these type of things. Maybe I think there are a lot of tools online where you can actually just like, if you know how to code a little bit,
Right.
you can just like go through the entire deep learning coding
Right. Right.
pipeline,
Right.
how to learn it. And if you don't know how to code, that's fine. Like, there are codes, like there are like good resources for like how to learn how to code about all of
Mhm.
these things. I think just like bit by bit learning and bringing up skills, and I'm sure like you wouldn't need for learning how to code. I think it's a very like a lot of coding learning that happens is between the friends, between the peers who
Yeah.
are working
Right.
together. You not necessarily need a very self like a very defined course for it. Just like use online tools like Coursera. See, like big universities have a lot of like beginner courses, take that. And like, if you like that course, good. If you don't like that course, like, that's fine, you move on to the next thing, because there are
Right.
so many things. But until you try that, you wouldn't know. So yeah,
Right.
just like, keep reaching out to people, keep reading like the papers that you guys are reading, and try to find summer programs for yourself.
Right.
That would
For
be,
sure.
and keep doing this like, so I think isolation, if you learn something in isolation, is very hard, and it's like
Mhm.
it's not like it's hard to continue. But like like how you're doing in a group, and I would like, tell to all the people who are in your club is like, just like keep doing these things together. You learn from each other. You are not gonna miss out. Like, nobody's gonna take anyone's space or
Right.
anybody's place. And
Right.
this world is too big to take someone else's
Right.
place. It's
Right.
not gonna happen. But if you learn together, that means like you have like two skill set working together, and
Right.
you learn more. So yeah, continue doing all of those
For
things,
sure.
and feel free to email me if
Hmm.
you are looking for some like, some resource that you can't find, or some papers that you are looking
Right.
to
Of
discuss. So yeah, like, keep reaching out to people, keep
course.
talking to people.
Yeah. I mean, you mentioned contents of the paper. Usually they go way over our head. Usually we're not able to keep up with all of it, but we just enjoy reading it. So I think that that's definitely
It's
a
a good thing. Like, so it is
right.
not just because like you are not doing the research in that field, that's why you are not able to understand. It happens to everyone. So let's say if
Right.
I start reading a paper that I'm not part of that research, or if I don't know that area at all, let's say if I read paper in quantum computing, I don't do quantum computing. So it will take me a while to understand like what's going on in that paper. But it's still like I might find something that I like.
Right. For sure. Yeah. Well, thank you so much, Dr. Chandio, for your time. I think you mentioned keeping in touch. I think that that's definitely a really good thing. We're from southern New Hampshire, so right above Massachusetts. So if that's a ever a possibility, we'd love to be in contact. So I really appreciate it. I really appreciate your time. Thank you so much.
Thank you.
Thank you.
Have
Have
a
a
good
great one.
night.
Right. Bye bye.
Bye.